program. I'm going to be talking about pixels for peace and how you can use Earth observation and AI to promote planetary security. Just to visualize what this looks like, let's see if I can get this to play. Yep, perfect. So Planet has the largest constellation of Earth-observing satellites in history. We actually have a constellation of hundreds of satellites that rotate pole to pole, imaging the entire Earth's landmass every single day in high resolution, about 3.7 meters per pixel. This is obviously incredibly valuable for seeing change over time, over large spaces. We also have a constellation of task satellites called SkySat. So these aren't just passively collecting over the Earth's landmass. They actually have to be pointed at specific points on the Earth, but are much more granular in terms of their resolution, capturing at about 50 centimeters per pixel and able to revisit locations multiple times a day. And importantly, Planet's a public benefit corporation, so we work not just with governments in the private sector, but with multilateral organizations, civil society, and I personally work on our impact program, which works in a philanthropic capacity with organizations to help build their capacity and build the use of Earth observation tools for peace and security use cases. And just to go into a little bit more detail of our specific instruments, this is our Super Dove satellite. Dove is not a coincidence. Our founders wanted our instruments to be used for peace and security use cases. This is the one that scans the Earth every single day or near daily. It collects 350 million square kilometers of imagery daily, so that's a huge amount of data to process, and it ends up being petabytes, multiple petabytes over the course of a year. But to see broad change in agricultural fields, in communities, seeing how populations are changing, it's incredibly valuable for those sorts of use cases. For our very high resolution satellites, so these are 50 centimeters per pixel satellites we currently call SkySat. That's very valuable for zooming in on change, so seeing things at the structure level, at the level of a ship, and seeing things like building damage and other key indicators of conflict and impacts to security. I'll just briefly touch on this one. This is one of our newer constellations called Tanager. It's a hyperspectral satellite. So those previous two sensors I described, they can see in about this many bands. Hyperspectral can see in hundreds of bands. So really valuable to see things that can't be seen by the human eye. Here's just an example of it detecting a methane emission. But there's a bunch of peace and security use cases that we still need to develop and prove out. I've been asked by organizations whether it can be used for detecting mass graves, for example, or seeing mass landmine placement, because there can be changes in the hyperspectral signatures of the soil where those are placed. And then looking a little further ahead, this is our Pelican constellation. We've actually just started launching these. This is the next generation of our task satellites. So this will go down from 50 centimeters down to 30 centimeters, and we'll be able to revisit 30 times per day and downlink the data within 30 minutes. So it's for peace and security use cases, for humanitarian use cases where you need data very quickly. This is going to be pretty transformational in terms of how it informs actors of what's going on the ground. And this is our newest constellation that we'll be developing over the next couple of years, and the one that I'm most excited about, which is called Owl. I think you've noticed that we like birds in terms of how we name our satellites. But this is going to be the next generation of our daily scans, so imaging the entire Earth's land mass every single day. But instead of 3.7 meters per pixel, it's going to go all the way down to 1 meter per pixel. So really going to start to blur the lines between the very high resolution sensors and the broad monitoring sensors that are typically anywhere from 3 meters to 10 or 20 meters per pixel. So what do we actually do in the peace and security sector? Well, we do a lot. I'm just going to highlight a few things that we do, since I don't have a lot of time. We inform just traditional analyses of conflict. This is some work that we've done with the Humanitarian Research Lab at Yale University. I believe they're giving a talk on Wednesday, so you should check that out. But they used our PlanetScope imagery, which is what we call the data derived from the daily scan constellation to monitor thermal scarring in agricultural fields in Jazeera in Sudan. And this is over the course of about a week's time. You can see the expansion of thermal scarring in those agricultural fields. Then using the very high resolution sensors, our SkySat imagery, they're able to determine damage to urban areas. So actually seeing building level damage, thermal scarring, shelling in this section of El Fasher. Then even going down more granular, they've used it to see the expansion of mass graves in Sudan over time and inform ongoing research into what those impacts are in Sudan. But that's just the kind of bread and butter work in terms of what we do with visual analysis of satellite imagery. We also fuse our data sets with artificial intelligence and machine learning. Over the past few years, we've had a very prolific collaboration with Microsoft's AI for Good Lab, and then Planet's also developed its own approaches to AI to do building damage assessments. The example you see here is for Lahaina in Hawaii in a natural disaster setting, but what we use here was actually first developed in Ukraine in 2022 after the Russian invasion, where we used high-resolution imagery plus these building damage assessment tools to assess damage to critical infrastructure in Ukraine. So looking at damage to sanitation facilities, damage to schools and hospitals, and give an early snapshot of what that looked like in the opening days of the conflict. But like I said, Planet's a mission-focused organization, so we've really tried to think about how we can lend our perspective as a private corporation that's producing this valuable data set to the peace and security sector. And actually part of our mission statement is we seek to accelerate humanity toward a more sustainable, secure, and prosperous world. So peace and security is actually part of our mission. And so with all these risk factors that we see emerging that Branko was talking about this morning and that have been present throughout all the panels today, an increase in climate-related disasters, impacts to nature, plant and animal species under risk over the next 5 years, increasing food and water insecurity, forced migration, pandemic risk, multilateral institutions collapsing and under risk, and then just the overall increase in conflict and fragility that has been a major theme of today, obviously. Planet wants to adopt a framework that tries to look at these intersecting themes and inform select projects that are examining these intersecting themes. So we're calling this Planetary Security. We just launched this new program in March that empowers 8 different partnerships, 8 different organizations with a data grant. They're looking at these thematic areas, and it's really meant to expand the bullseye, or quote unquote expand the bullseye of what we think of as security. So not just traditional national and international security concerns, but also all the things that have been part of the multilateral and civil society understanding of risk. So things like climate security, nature security, biosecurity, critical minerals and energy security, peacemaking, human security, and food and water security. None of this is new. This is stuff that all the organizations here have been talking about for a long time, but we want to help contribute to that framing of these risks over the long term. Just to highlight a few of the organizations that we're working with under this program, we've been working with the UNDP's Crisis Bureau to provide imagery for their assessments in post-conflict settings. This is an example from Gaza where they used a satellite-derived damage assessment to estimate rubble in Gaza. And this actually used a building damage assessment derived from our SkySat. So this is the 50 centimeter per pixel imagery. All the red pixels you see there, those are damaged buildings. And then the purple pixels are new structures. So these are IDP camps and greenhouses and other signs of forced displacement within Gaza. We're also working very closely with the Halo Trust, so it's great to hear what the Carter Center is doing for humanitarian demining. Similar to what other organizations do, the Halo Trust uses high-resolution imagery to see indirect evidence of conflict. It's obviously very hard to see an individual landmine or even a row of landmines from space, but there's a lot of indicators in the data that can show where landmines may be placed. So looking at things like berms, trenches, military structures to see where there might be possible contamination of unexploded ordnance. They also use our daily scan imagery to look at changes in agricultural cultivation, because that can actually be a very good indicator of possible contamination. If you look at trends over time of consistent cultivation, and if that suddenly stops, or any sorts of irregular signals in cultivation, that can be a sign that an agricultural field is potentially contaminated with unexploded ordnance, whether it's landmines, unexploded artillery shells, et cetera. And here they actually use something called NDVI, which is assesses vegetation density in the satellite imagery. And here's another example of them looking at field boundaries for which land is cultivated and not cultivated in Syria. And this work is also expanded to Ukraine. They've been working along the front lines of Ukraine for a long time, obviously, understanding the risks. Similarly, using indirect evidence, looking at former tank positions, Russian military positions, because from that they can derive where possible landmine placement is, and then use that for their non-technical surveys where they need to prioritize their assessments. And then similarly, using agricultural land assessments to determine possible contamination. And then here, this is actually derived from the same building damage assessment in Gaza that UNDP used. They are using building level explosive hazard assessments so they can determine where possible unexploded ordnance is based on building damage in Gaza. Then lastly, the last one I'll highlight is RAPID, which is a collaboration between Planet, NASA Harvest, Microsoft's AI for Good Lab, Google.org, and the Rockefeller Foundation. This is actually expanding on work that we did originally in 2022 to assess impacts to food systems in Ukraine following the start of the conflict. But we want to expand that work to all conflict areas, so not just Ukraine, but also Sudan, Lebanon, and beyond. So create a global monitoring service so food shocks can be determined using both satellite imagery and other data sets, and then inform policymakers and first emergency responders on what its impacts may be. I have a lot more that I want to talk to you about. One thing I'll just quickly plug is we do have a new AI app that uses natural language, large language models to interact with Planet's imagery. We're in a closed beta right now, but I'll circulate an invite to that closed beta if you want to explore whether it's valuable for your organizations. Thank you so much.